Hello students. So today I am doing class for class 12 science and I welcome you all in this class. So today we will start continuity of a function f of x. Okay, so usually you know that a function is represented by f of x, right? A function is denoted by f of x. That is, function of x, any expression in terms of x is expressed as a function of f of x. Okay, so before I explain you about continuity of a function, let us draw the graph of some equation. Okay, suppose if you have y is equal to 0. So what does it represent? So y is equal to 0, it is an equation. Actually, what does it represent? So let us draw the graph of y is equal to 0. Okay, so how can you draw the graph of y is equal to 0? So I think you have done it in class 9, I think. Okay, so how can you draw the graph of y is equal to 0? What does it represent actually? Okay, we can draw the table out here, like so. Draw the table first for y is equal to 0. Okay, for y is equal to 0, and this f of x can be written as y also. Let y is equal to f of x. Okay, and here this f of x is equal to 0 actually. F of x is equal to 0 means y is equal to 0. So we have assumed y is equal to f of x, so it is y is equal to 0. Actually, what does it represent now? Okay, now if y is equal to 0 is there, y is equal to 0, it is a constant value of y. So let us write x and here y. So here the value of y is constant, which is equal to 0. तो यहाँ चाहिँ के दिएको छ भन्दाखेरि y is equal to 0. y को भ्यालु चाहिँ 0 0 0 0 कन्स्ट्यान्ट बस्छ सबैमा. यो चाहिँ x को भ्यालु जतिसुकै होस्, x को भ्यालु जतिसुकै होस्, y को भ्यालु चाहिँ कति हुन्छ? 0. अब x को भ्यालु हामी कुनै पनि हाल्न सक्छौं. Let us write 0 1 2 -1 -2. Is that clear to all of you? Now let us draw the graph of this table. Okay, so we have to consider x-axis and y-axis. You know that, right? This is your y-axis and this is your what? This is your x-axis. So x o x dash and this is your y o y dash, right? So let us consider here. So on the right hand side of x-axis, that is on the right side of y-axis, all the values of x are positive here, and on the left side of y-axis, all the values of x are negative here. So above this x-axis, all the values of y are positive in this case, and below x-axis, all the values of y are negative out here. So suppose this is +1, +2, +3, +4, etc. right? And here all the values of x are negative here, -1, -2, -3, and this is your -4, right? So above the y-axis, suppose this is +1, +2, +3, etc. Below y-axis, it will be -1, -2, etc. right? So let us mark the first point, that is x is equal to 0, y is equal to 0, that is 0, 0. This O is the origin. This is 0. 0, 0 lies out here. Okay, so this point is actually origin, right? So it is 0, 0. Where does it lie? It is the origin. It is the origin 0, 0. 1, 0 lies out here. You know that. 2, 0 lies out here. And -1, 0, -1, 0 lies out here. -2, 0 is here. So if you join all these points, you will get which axis? X-axis. That means, what does y is equal to 0 represent? Y is equal to 0 represents x-axis. So y is equal to 0 represents what? It is the x-axis. So I think you have understood it. So y is equal to 0 represents what? represents x-axis. So what is the equation of the x-axis now? It will be y is equal to 0. So I think you have understood it. So let us draw the graph of other equation, that is if you have f of x, that is f of x is actually y, isn't it? Function of x. Now it is given x is equal to 0. Suppose it is given x is equal to 0 only. So the value of x here is 0. So x is equal to 0. What does it represent? X is equal to 0. Let us draw the graph of x is equal to 0. Okay. So x is equal to 0. Here the function of x is x. Here the function of x is x. F of x is equal to x. Right. And here x is equal to what? It is 0. Right. X is equal to 0. So now let us draw the table first. So let us draw it here. X is equal to 0. Suppose this is x and this is your y. Okay. Suppose it is x and this is y. Right. Now here all the values of x are 0 here. Because x is equal to 0 is constant. So x will be 0. X को value चाहिँ के भयो 0 भयो. अब y को जुनसुकै बेला हाल्दा पनि हुन्छ. Y may vary out here. Okay. So it is 0, 2, or you may write 1, 2, -1, -2. So let us draw the graph of this table. Okay. So x is equal to 0. What does it represent now? So this is your y-axis. This is your x-axis. Okay. So it is x o x dash. This is your y o y dash. Right. So 0, 0. First of all, mark this point 0, 0. So it is 0, 0 lies out here. Okay. Suppose this is 1, this is 2, this is 3, this is -1, -2, and this is your -3. So this is 1, 2, 3, and this is your -1, -2, -3, and so on. Right. So mark the point 0, 0. Where does it lie? It is the origin 0, 0. Okay. 0, 1. Which is 0, 1? 0. X is equal to 0. 0 lies out here. 1 goes up here. 0, 1. 0, 2. 0, 2. 1, 2. Next 0, -1. 0 is here. -1 comes out here. And 0, -2. 0 is out here. And -2 is this one. So if you join all these points, you will get a graph, isn't it? You will get this y-axis. So what does x is equal to represent? X is equal to 0 represents the y-axis. So x is equal to 0 represents what? Represents y-axis. So x is equal to 0 represents y-axis. So y is equal to 0 will represent x-axis, and x is equal to 0 will represent y-axis. That is the equation of the y-axis is x is equal to 0. Is that clear now? So let us draw the graph of other equation. That is, let us draw the graph of y is equal to some constant. Suppose the constant is 3, right? So let us draw the graph of y is equal to 3. So 3 is a constant here. Y is equal to 3 is a constant, right? So y is equal to 3 is a constant out here. So let us draw the graph of y is equal to 3. So what does it represent? Again, draw the graph. Again, draw the graph of this equation. So this is x and this is y. Now the value of y is constant out here. It is 3, 3, 3. It will not change. The value of y is always 3. But here in this case, the value of x will change. That is 0, 1, 2, -2, -3. So let us draw the graph of this equation. Y is equal to 3, right? So this is your x o x dash. This is your y o y dash. So 0, 3, where does it lie? So now let us mark the point out here. This is your origin. This is your 1, 2, 3, 4, right? This is -1, -2, -3, and so on. This is your -1, -2, this is -3, and here it is 1, 2, and this one is 3, right? Now where does this point lie? 0, 3. 0, x is equal to 0 is out here, and 3, 1, 2, 3. This is your 3, right? And 1, 3, where does it lie? 1 is out here, 3 goes up out here. Okay, 2, 3, 2, x is equal to is 1, 1, 2, 3 goes up. This is your 3. Again, -2, 3, -2, 3. -2, 3 lies out here, isn't it? So let us mark this point. One is -2, 3. One is -2, 3. And what is the other one? -3, 3. Okay, so you have to understand it, right? So before we do continuity of this function, let us know how to draw a graph of y is equal to 3 or y is equal to constant. Okay, so what does it actually represent? So -2, 3, where does it lie? -2, 3, -2 comes out here and 3 goes up. This is 3. Then -3, 3, -3 comes out here and 3 goes up out here. So if you join all these points, you will get a straight line. You will get a graph which is a straight line, and the equation of this straight line is y is equal to 3. So what is y is equal to 3? Y is equal to 3 represents a straight line which is parallel to which axis? X-axis. Is that clear? So now I think you have understood it. So y is equal to 3 represents a straight line which is parallel to which axis? X-axis. Is that clear? So let us do next one. So in this case we can write down that y is equal to k, where k is a constant. K may be 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, etc. It may be fraction also. That is y is equal to 2 by 3, 3 by 4, 3 by 6, 3 by 9, 3 by 10, etc. So y is equal to constant will represent a straight line which is parallel to x-axis. So y is equal to k represents a straight line, which is parallel to x-axis, which is parallel to x-axis, which is parallel to x-axis. So you know that similarly x is equal to k. Similarly, x is equal to k represents a straight line. Similarly, x is equal to k represents a straight line which is parallel to which axis? Which is parallel to y-axis. Is that clear now? So x is equal to k represents a straight line which is parallel to y-axis. So number one is y is equal to 0 represents x-axis, x is equal to 0 represents y-axis, y is equal to k represents a straight line which is parallel to the x-axis, and x is equal to k represents a straight line which is parallel to the y-axis. So I think you have understood it. Okay, so now let us draw the graph of this function now. So let us draw the graph of this function, that is, let f of x is equal to 1 when x not equal to 0. Let f of x is equal to 1 when x not equal to 0. Okay, here function of x is 1. Since 1 is a constant, this is known as constant function. So f of x is equal to 1 when a condition is given out here, when x not equal to 0. So is equal to 0 when x is equal to 0. So let us draw the graph of this function. So before I explain you about continuity of a function, let us draw the graph of this function. Okay, So I think you have understood it. So number 1 is y is equal to 0, 0 represents x-axis. Number 2, x is equal to 0 represents y-axis. Number 3, y is equal to k represents a straight line which is parallel to x-axis. And this number 4, x is equal to k represents a straight line which is parallel to the y-axis. So I think you have understood it. Okay. Now let us draw the graph of this function now. So let us draw the graph of this function. So let f of x is equal to 1 when x not equal to 0. So what is meant by x not equal to 0? Either x is greater than 0 or x may be less than 0. So x not equal to 0 means either x greater than 0 or x may be less than 0. So you know that x greater than 0 भनेको के हो? X greater than 0 भनेको positive and x less than 0 भनेको negative. You know that, isn't it? So f of x is equal to 0 हुन्छ कति बेला? When x exactly equal to 0. So f of x is equal to 0 हुँदैछ कति बेला? When x is equal to 0. Now let us draw the graph of this function. Okay? So this f of x can be written as y. Let y is equal to 1. When is it so? Y is equal to 1 when x greater than 0 or x less than 0. And it is exactly equal to 0 when x is equal to 0. Now let us draw the graph of this function. Okay? So now so this is your x, O, x dash. This is your y, O, y dash. Okay? Now let us draw the graph of this function. This given function. So suppose this is 1, 2, this is 3 and this one is 4. This is your minus 1, minus 2, minus 3, minus 4 and so on. So up out here, this is 1, this is 2, this is 3, and this is minus 1, this is minus 2, and this one is minus 3, right? Now in this case, y is equal to 0 when x is equal to 0. That means 0, 0 is a point, which is the origin, isn't it? So this is the point, 0, 0 is the origin. Is that clear to all of you? Now in this case, when x greater than 0, when x greater than 0, y is equal to 1, you can draw the table here also. You can draw the table here also. So let us draw the table now. Just try to understand it. Don't copy it. Okay? Don't copy it. Just try to understand it. So what type of graph will you get out here? Okay? So now, suppose this is x and this one is y. Now it is given that x greater than 0. So 0.1 is also greater than 0, you know that. 0.01 is also greater than 1, isn't it? So in this case, let us write here x greater than 0 means 0.1. Then you can write here 1, 2, etc. because x is greater than 0 out here. But if x is greater than 0 out here, you can't take x less than 0 in this case, okay? But the value of y is constant, y is equal to 1. So you can write here y is equal to 1. So we can draw the graph of this table, isn't it? So let us draw the graph of this table. X 0.1. X 0.1 means just out here. And y is equal to 1 goes out here. Right? So next one is 1, 1. So where does it lie? 1, 1. 0. 1, 1 goes out here. 2, 1. 1, 2, 2, 1 goes out here. Again 3, 1, 4, 1 will be there, isn't it? So from this point we can draw the straight line which is parallel to x-axis. Is that clear to all of you? But this straight line will not touch this point 1 because it is given strictly x greater than 0. If x is strictly greater than 0, then this straight line will not touch the y-axis because x is greater than 0 is given here. X greater than 0 means on the right side of y-axis you have to draw the straight line. Is that clear? So this straight line will not touch the y-axis. So in this case, you will draw like this. That means this straight line will not touch the y-axis, because in this case x is strictly greater than 0. X is strictly greater than 0 means you have to draw a straight line on the right side of y-axis. Is it clear now? So next, now let us draw the graph of x less than 0. If x less than 0, then it is y is equal to 1. So let us draw the table out here again. Let us draw the table out here. So this is x and this is y. This is x and this is y. Okay. So what is the value for x here? X is less than 0. That means x exactly not equal to 0. That is x less than 0 means it may be 0, minus 0.1, minus 1, minus 2 and so on. Right? So if you have minus 0.1, x less than 0, then also it is y is equal to 1. So here you can write 1, 1, 1, because y is equal to 1 is always constant. Whatever may be the value of x, y is always constant, which is equal to 1. Is that clear now? So next, what will you do here? Let us draw the graph of this table. Minus 1 minus 0.1 goes out here. Then comma 1. This is your, this point is 1, and this is your minus 0.1 comma 1. Then comes minus 1 comma 1, minus 1 comes out here, 1 goes out here. Then minus 2 comma 1, minus 2 comes out here, then 1 goes out here. So from this point you have to draw a straight line on the left side of y-axis. It goes to infinity. So it may be minus 3 comma 1, minus 4 comma 1, minus 5 comma 1. It goes up to infinity. That means you can draw a straight line up to infinity. Okay, but this straight line will not touch the y-axis because it is given x is less than 0. If it is given x less than 0, then you have to draw the straight line on the left side of y-axis. Okay, and this straight line will not touch the y-axis. So that means this graph, when x is equal to 0, f of x is equal to 0, or when x is equal to 0, y is equal to 0. It is 0. So is it the continuous graph? It is the continuous graph. So here in this case it is discontinuous, isn't it? So the graph is said to be continuous if you can draw the graph without lifting the pen. But in this case we have lifted the chalk out here. So if you can draw the graph without lifting the chalk, then this is known as continuous graph. But in this case, this is not continuous because there is a break out here. यहाँ चाहिँ के भयो एउटा ग्याप भइगयो. यो ग्याप भयो केमा चाहिँ ग्याप भयो? यो y axis मा चाहिँ यो के भयो? ग्याप भइगयो. That is at x is equal to 0, there is a gap. So x is equal to 0 is known as the point of discontinuity out here. त यो ग्राफ बनाउँदा चाहिँ हामीले कन्टिन्युअस बनाउन सकेनौ किनभने यहाँ बीचमा चाहिँ के भयो एउटा ग्याप भइगयो. So the graph is continuous if you can draw the graph without lifting the chalk or without lifting the pen or without lifting the pencil. That is known as the continuous graph. The graph is continuous if you can draw the graph without lifting the chalk or without lifting the pen or without lifting the pencil. Okay, so this graph is discontinuous because there is a gap out here. Okay, so यो चाहिँ भयो एउटा discontinuous graph भइगयो. अच्छा, अब म एउटा एक्जाम्पल देखाउँछु. कन्टिन्युअस ग्राफको म एक्जाम्पल देखाउँदैछु. ठीक छ? So let us draw the graph of this function. So let us write down let y is equal to within mod x. Let y is equal to within mod x, or you may write here let f of x is equal to within mod x. This is known as modulus of x. Modulus of x means the values of x must be always positive. This is read as modulus of x. That means the value of x should be positive always, right? Now in this case, so how can you simplify this modulus sign? So first of all, if the expression is kept within modulus sign, you must check when is this value of x 0. So यो जुन चाहिँ within mod एउटा expression छ, यो x को value कति बेला 0 हुन्छ? If you put x is equal to 0. यो x को value कति बेला 0 हुन्छ रे? If you put x is equal to 0, then this f of x will be 0. Okay? So at what value of x this f of x will be 0? First of all, you check that. If x is equal to 0, then f of x will be 0. Okay? If x is equal to 0, then f of x is equal to within mod 0, which is equal to 0. Is that clear now? So next, now you should check if x greater than 0. If x is greater than 0, x is already positive, isn't it? If x is greater than 0, f of x is already, this x is already positive. Then what is the value for f of x? Then f of x is equal to what? Then f of x is equal to x. Then f of x is equal to x. If x is greater than 0, then if you write only x, that will be always positive. So f of x is equal to x. ठीक छ? जब x greater than 0 हुन्छ, त्यतिबेला x को भ्यालु पोजिटिभ भयो त. त x पोजिटिभ भयो भने no need of putting this mod sign. So you just write only x. So if x is greater than 0, then f of x is equal to x because x is already. Now if x is equal to 0, then f of x is equal to within mod 0 is equal to 0. That means it is neither positive nor negative. 0 भनेको positive पनि हैन negative पनि हैन. हैन? So if x is greater than 0, now if x is greater than 0, then f of x is equal to x because x is already positive. If you write x is greater than 0, then x is already positive. Then f of x is equal to, you should write only x because x is already positive. Is that clear? Now if x less than 0, then what is the value for f of x now? If you write only x, so look at the blackboard, what happens here is that if x is less than 0, x less than 0 means x is always negative. So if you write only x, this x is already negative, but you should make it positive because you know that within mod x means its value must be always positive. So to make it positive, you should write here minus sign. Is that clear to all of you? You can copy it. You can copy it. Okay? So now, so if you write x less than 0 and if you write only x out here, f of x is equal to x, then it will be negative. Suppose if I don't write negative sign out here, if x is less than 0, then f of x is equal to x. If you write only x, this is already negative, isn't it? If you write down the condition x less than 0, then f of x is equal to x is already negative. But you should make it positive because you know that within mod x means it should be always positive. त मैले यहाँ के भन्दैछु भन्दाखेरि यदि तिमीले x less than 0 लेख्यो x भनेको त नेगेटिभ हो. तो यो x पनि के हुन्छ नेगेटिभ, तर यसलाई हामी के भन्नुपर्छ पोजिटिभ. किनभने विदिन मोड x भनेको नै x को भ्यालु चाहिँ जहिले पनि के हुनुपर्छ, यसको भ्यालु चाहिँ जहिले पनि पोजिटिभ हुनुपर्छ. त x त अलरेडी नेगेटिभ भएको, यसलाई पोजिटिभ बनाउनु भने अगाडि के मल्टिप्लाई गर्नुपर्छ, माइनस साइनले मल्टिप्लाई गर्नु पर्यो. So I think you have understood it. Okay? So now what will you do here now? So now can you write here x greater than or equal to 0? So we can check it from here. If x exactly equal to 0, then f of x is equal to 0. If you write x is equal to 0 out here, greater than or equal to 0, that means if you write x is equal to 0, then the value of x will be 0. Isn't it? So you can write here greater than or equal to. So in this case, x less than 0, it is strictly less than 0. Can you write is equal to 0 out here again? So if you put x is equal to 0, then this x is 0. Minus 0 means always 0. So you can write here is equal to sign. Okay? Now let us draw the graph of this function. So f of x is equal to within mod x means its simplified form is this one. That is, if x is equal to 0, then f of x is equal to 0. If x greater than or equal to 0, then f of x is equal to x. If x is less than or equal to 0, then f of x is equal to minus x. Is that clear now? So let us draw the graph of this function. Okay? X is equal to 0, 0, 0, that is a point. You know that, isn't it? So now, what we will do here is, let us draw the graph of f of x is equal to x. So here you can write, instead of f of x, I already told you that instead of f of x, you can write y. So let y is equal to x out here. Okay? So now let us draw the table now. Let us draw the table out here. So this is x and this is y. So what are the values of x that you can put out here? X is greater than or equal to 0. You can start from 0 out here. So you can put x is equal to 0. If you put x is equal to 0, and according to this equation y is equal to x, if you put x is equal to 0, what is the value for y? That is also 0. Put x is equal to 1 now. You can put x is equal to 1 because x is greater than 0. You can put x is equal to 1. If you put x is equal to 1, what is the value for y? 1, because y is equal to x is given out here. You can put x is equal to 2 now. If you put x is equal to 2, y is also 2. You can put 3, y is equal to 3. You can put x is equal to 4, y is equal to 4, and so on. It goes up to plus infinity. It may be 10, 10, 100, 100, 1000, 1000, and so on. It goes up to plus infinity. Is that clear? Now let us draw the graph of this function. This one, let y is equal to minus x. So let us draw the graph of this function y is equal to minus x. So let us draw the table out here. So this is x and this is y, right? So in this case, what are the conditions for this equation? It is given x less than or equal to 0. You can put x is equal to 0 out here. If you put x is equal to 0 out here, x is equal to 0, y is also minus 0 means 0. Because 0 has neither negative nor positive sign. Okay? Now, since x is less than 0, you can put minus 1 out here. If you put x is equal to minus 1, minus 0 minus plus, y is equal to plus 1. You can put minus 2. If you put minus 2, minus 0 minus plus 2, y is equal to plus 2. You can put minus 3, y is equal to 3. You can put x is equal to minus 4, y is equal to plus 4, and so on. It goes up to minus infinity. The values of x goes up to minus infinity. Okay? So you can have infinite number of values of x there, and you can have infinite number of values of y out there. So let us draw the graph of this first table. Okay? So now it is x o x dash, this is your y o y dash. So this is 1, this is 2, this is 3, this is your plus 1, plus 2, plus 3. This is the positive side of x-axis, this is the positive side of y-axis, this is the negative side of x-axis, and this is also the negative side of y-axis. This is the negative side of y-axis. Is that clear? So now we will draw the graph of that table first. Okay? So first table. Now 0, 0. X is equal to 0, y is equal to 0. That means 0, 0 is the origin. Then next point is x is equal to 1, y is equal to 1. X is equal to 1 means this one, and y is equal to 1 goes out here. Right? Then comes x is equal to 2, y is equal to 2, 2. 2 means x is equal to 2 means 1, 2, and y is equal to 2 means up out here. You can add 3, 3, 4, 4, and so on like that. Okay? It goes up to plus infinity. So join these points, you will get a straight line. It goes up to infinity. But you cannot draw a straight line below this point out here. Why? Because it is given x is greater than 0. So if x is greater than 0, positive side of x-axis means on the right side of y-axis. Positive side of x-axis is this one, on the right side of y-axis. So you have to draw the graph from this origin up out here. It goes up to infinity. But you cannot draw the graph below this point. because it is given that x is greater than 0. But it is not x less than 0. That's why you cannot draw the graph on the negative side of x-axis. Okay, so that's why you cannot draw the graph below this point. So it goes from this origin up out here, it goes up to infinity. Is that clear? The next one. Let us draw the graph of this second function. That is, if x less than or equal to 0, then f of x will minus x. And we have assumed this f of x as y. So let y is equal to minus x. So let us draw the graph of this table first. Okay. So x is equal to 0, y is equal to 0 means 0, 0 comes out here. Okay. Minus 1, 1. X is equal to minus 1, y is equal to 1. Minus 1 goes out here. X is equal to minus 1. And y is equal to 1 comes out here. This is your minus 1, 1. You know that. How to plot the point, isn't it? So next, x is equal to minus 2, y is equal to 2. X is equal to minus 2 means x equal to minus 2 comes out here and y is equal to 2 goes out here. Similarly, we can have infinite number of points out here. Okay? Which goes in this direction. So join all these points. You will get a straight line which goes up to plus infinity. Okay? So it goes up to plus infinity, it goes up to plus infinity. Now here also, you cannot draw the straight line below this point. Why? Because it is given x less than 0. X less than or equal to 0. But it is not x greater than 0. If it is x less than 0, then you have to draw the graph on the negative side of x-axis only. That means the graph goes in this direction only. But you cannot draw the graph below this point because it is not given here x greater than 0. But it is given x less than 0. Okay? So now, while drawing this graph, do you see any gap out here? No gap is there. Here we are drawing the graph or we are drawing the straight line without lifting the chalk out here, isn't it? So this is a continuous graph. That is, f of x is within mod x is a continuous function. Use your continuous function by you. This is a continuous graph. So this is a continuous function. That is, f of x is equal to within mod x. That is, modulus of a variable is a continuous graph. Is that clear to all of you? Now we'll discuss about the continuity of a function with the help of a limit. So this is with the help of the graph. We have discussed the continuity of a graph and the discontinuity of a graph. Now we will discuss the continuity of a function with the help of limit. Okay, so we'll do that one now. Now let us discuss the continuity of a function with the help of a limit. So I told you about the limit, isn't it? So when you write limit x tends to a, or you may write it as LT x tends to a. A is any positive number or any negative number. It may be 0 also. A may be any number, any arbitrary number, any number that is defined in this universe, right? So x tends to a. What do you mean by limit x tends to a? I told you that. So this is, let us consider a number line. This is x is equal to a. This is x is equal to a. So limit x tends to a means x is tending or x approaches a from the left hand side or from the right hand side. So x is approaching towards a, x is approaching towards a either from the left hand side or from the right hand side. If x approaches towards a constant quantity a, if x approaches a constant quantity a from the left hand side, then this is known as left hand limit. Then it is known as what? Left hand limit. If x approaches towards a constant quantity a from the right hand side, that is known as right hand limit. That is known as what? Right hand limit. That is known as what? Right hand limit. Is that clear to all of you? Now usually this left hand limit is denoted by limit x tends to a minus. If you write limit x tends to a minus, this means that x is approaching towards a constant quantity a from the left hand side only. Is that clear? That is limit x tends to a minus, or you may write LT x tends to a minus. Is that clear to all of you? And this also indicates that x is less than a. So left hand limit लेख्दाखेरि हामी के डिनोट गर्छौं भन्दाखेरि limit x tends to a minus or LT x tends to a minus. LIM x tends to a अलिकति माथि पनि माइनस साइन लेख्नु, or LT x tends to a अलिकति माथि हामी के लेख्छौं minus. So what does it indicate? X is approaching towards a from the left hand side only. Is that clear? Now right hand limit is denoted by what? Limit x tends to a plus. Limit x tends to a plus, because in this case x is approaching towards a from which side? Right hand side, and all the values of x on the right hand side is greater than a. On the left hand side of x is equal to a, all the values of x are less than a. On the right hand side of this x is equal to a, all the values of x are greater than a. That is, x is greater than a. So what does it indicate? Limit x tends to a plus indicates that x is approaching towards a from which side? From the right hand side only. Or you may write, or LT x tends to a minus. Limit x tends to a plus. Limit x tends to a plus. Either you can write LIM x tends to a plus, or you may write LT x tends to a plus. So what does it indicate? X is approaching towards a from which side? Right hand side only. Is that clear? So in this case you can write down the function also. This is function of x. This is also function of x. Okay. Now in this case, if right hand limit is equal to left hand limit, if this right hand limit is equal to left hand limit, then the limit exists. Okay. So if limit x tends to a plus, f of x is equal to limit x tends to a minus f of x. Okay, then the limit exists. Then the limit exists. If the right hand limit is equal to the left hand limit, then the given limit exists. Otherwise, if they are not equal, the limit does not exist. Is that clear to all of you? So now, for the continuity of a function, you have to get the value for f of x. Now in this case, x tends to a plus, x tends to a minus means x exactly not equal to a. Either it is approaching towards a from the right hand side, or it is approaching towards a from the left hand side. Okay, but x exactly not equal to a. Okay, now if you write f of a, what is meant by it? What do you mean by f of a? The value of the function f of x when x exactly equal to a. So what does it indicate? The value of the function f of x when x exactly equal to a. Okay, this f of a means the value of the function f of x when x exactly equal to a. But in this case, limit x tends to a plus f of x means in this case you cannot put x is equal to a. X is not exactly equal to a. Either x is approaching towards a from the right hand side, or x tends to a minus means it is approaching towards a from the left hand side. X tends to a plus means x is approaching towards a from the right hand side, but x exactly not equal to a. X tends to a minus means this function f of this x is approaching towards a from the left hand side, but x exactly not equal to a. But what do you mean by f of a? This is the value of the function f of x when x exactly equal to a. Is that clear now? So for continuity of a function, you have to get the right hand limit, the left hand limit, and the value of the function at the given point, that is x is equal to a. If all these three are equal, then this is known as continuity. Then the function f of x is continuous at the given point x is equal to a. Okay? So in case of continuity, you have to find out the right hand limit of the function. You have to find out the right hand limit of the function at a given point. Also, you have to find out the left hand limit of the function at a given point. And also, you have to find out the value of the function at the given point. The value of the function at the given point. If all these three are equal, then you can say that the function f of x is continuous at a given point. Okay? So let us write down the definition now. That is known as the mathematical definition of continuity of function f of x. Okay? Now write down definition DEFINITION, definition of continuity. Definition. Write down. You have to write down this definition. Definition of continuity. Definition of continuity of a function. At a given point. At a given point, right? So let us write down the definition now. The function f of x is said to be is said to be continuous. The function f of x is said to be continuous at a given point. Let us say x is equal to a. The function f of x is said to be continuous at a given point x is equal to a, comma, if. So first of all, you have to write down the right hand limit. How can you write down the right hand limit? Limit x tends to a plus f of x. This is your right hand limit. Okay? Because x is approaching towards a from the right hand side, but x exactly not equal to a. Is that clear? Is equal to limit x tends to a minus f of x. This is your left hand limit because x is approaching towards a from the left hand side only, which is equal to, this is your f of a. That is, f of a means the value of the function f of x when x is equal to a. So if all these three are equal, then only the function f of x is said to be continuous. So I think you have understood it. This is known as the mathematical definition of continuity of a function. Or you may write down the definition as, or in other words, you can write down that the function f of x is continuous. The function f of x is continuous at a point x is equal to a, comma, if number one, f of a is defined. You have to get the value of the function f of x at x is equal to a. That should be always defined. Okay, some value of, that is, function of x is given. The function of x is given, that is f of x is given, and also a point is given. If you put that value of x at that function should be defined at that point. That is, f of a is defined. That is f of x has a definite value has a definite finite value. Definite finite, F-I-N-I-T. What do you mean definite finite? That it should be defined always. It should not be undefined. Undefined chahunu bhaina. That is, you have to get the value of the function f of x when x exactly equal to a, and that f of a should be defined. That is, f of x has a definite finite value at x is equal to a. Is that clear? त तिमीले यहाँ के को भ्यालु निकाल्छौ, f of x को भ्यालु निकाल्छौ at a given point, suppose it is x is equal to a. त त्यो f of a चाहिँ के हुनु पर्छ, डिफाइन हुनु पर्यो. f of a चाहिँ अनडिफाइन हुनु नै हुँदैन. अनडिफाइन भने चाहिँ डिस्कन्टिन्युअस भइहाल्छ. अनडिफाइन भने के हुन्छ रे, डिस्कन्टिन्युअस. ठीक छ? So f of a should be defined. That is, f of x has a definite finite value at x is equal to a. एउटा कन्डिसन satisfy हुनु पर्यो. Number two, the limit should exist. That is, limit x tends to a plus f of x is equal to what? Limit x tends to a minus f of x. That is, the limit exists. If right hand limit is equal to left hand limit, the limit exists. That is, the limit exists. That is, the limit exists. Okay, so if limit x tends to a plus f of x is equal to limit x tends to a minus f of x, that is, the limit exists. Okay, so if right hand limit is left hand limit, then the limit exists. So if the limit exists, then you can write down the value of this limit, isn't it? That is, limit x tends to a f of x. If limit x tends to a plus f of x is equal to L, small l, and if limit x tends to a minus f of x is equal to also L, then the limit exists, and then you can write down the value of this limit, that is, limit x tends to a f of x is equal to L. Is that clear? So you can get the value for limit x tends to a f of x is equal to L. Okay? And number three is, what can you write? If both these limits, that is right hand limit is left hand limit, then you can write down the value for limit x tends to a f of x. Okay, and it should be equal to f of a, which is equal to f of a. All these three conditions should be satisfied in order to get the function f of x to be continuous at a point x is equal to a. Okay, so all these conditions should be satisfied so that the function f of x may be continuous at a given point x is equal to a. So this first one is the mathematical definition of continuity, and the second one is the theoretical definition of continuity. You should know all this, you should know both this definition in order to do the problem. Okay, so this is known as the mathematical definition of continuity, and this is known as the theoretical definition of continuity. Okay, so you can copy it. So now we have discussed the definition of continuity of a function f of x. Now let us do the definition of discontinuity of a function f of x. Now discontinuity of a function f of x. Discontinuity of a function f of x, right? त अघि मैले तिमीहरुलाई ग्राफ अनुसार चाहिँ देखाए discontinuity of the graph. Okay, now how can we define discontinuity of a function f of x mathematically? So how can you define discontinuity of function f of x? So one point is, for discontinuity, right hand limit should not be equal to left hand limit should not be equal to right hand limit. Okay, the function f of x is said to be discontinuous at a point x is equal to a if right hand limit at that point not equal to left hand limit at that point. Okay, So this is one of the definition. Sometimes you may get right hand limit is equal to left hand limit, but that is not equal to the function of f of x at the given point. Is that clear now? So let us write down the definition first. The function f of x, the function f of x is said to be discontinuous, is said to be discontinuous, is said to be discontinuous at a point x is equal to a comma if what will you write? If f of a is undefined, f of a is undefined. त तिमीलाई के दिएको छ? f of x को एउटा भ्यालु दिएको हुन्छ. So at a given point, suppose x is equal to a, if you put x is equal to a, and if you can get f of a as undefined value, then you can directly write down that f of x is discontinuous at the given point x is equal to a. That is, f of x has an infinite value. Infinite means undefined. F of x has an infinite value at x is equal to a. So if you get this condition, that is f of a is undefined or f of x has an infinite value at that point x is equal to a, so directly you can write down that the f of x is discontinuous at that point. Okay, or it may be, or limit x tends to a plus f of x not equal to limit x tends to a minus f of x. That is, right hand limit is not equal to left hand limit. That is, the limit does not exist. That is, the limit does not, exist. Then the function f of x is discontinuous. तो कोही बेला के हुन्छ, यो दुईटाको भ्यालु निस्किन्छ, कोही बेला डिफाइन आउँछ, दुईटा इक्वल पनि हुन सक्छ, or but if both this right hand limit is equal to left hand limit, I told you that you can write down the value of this limit, that is limit x tends to a f of x. If right hand limit is equal to left hand limit, you may get that. If right hand limit is equal to left hand limit, then you can write down the value of that limit, that is limit x tends to a f of x. Or but this should not be equal to f of a. Okay, or limit x tends to a f of x. If right hand limit is equal to left hand limit, you may get, but if right hand limit not equal to left hand limit, the limit if right hand limit not equal to left hand limit, then the function f of x is discontinuous by us. Sometimes you may get right hand limit is equal to left hand limit, that is the limit exists, but it should not be equal to f of a. So if right hand limit is equal to left hand limit, then you can write down the value for limit x tends to a f of x, but that limit x tends to a f of x should not be equal to f of a. That is, limit x tends to a f of x should not be equal to f of a. Then the function f of x is discontinuous at x is equal to a. So the function f of x is said to be continuous if f of a is undefined, that is f of x has an infinite value at x is equal to a, that is your discontinuity. Or it may be, sometimes you may have defined value for f of a. You may get limit x tends to a f of x not equal to limit x tends to a minus f of x, that is right hand limit not equal to left hand limit, that is the limit does not exist. In this case also the function f of x is discontinuous. Okay, sometimes you may get that right hand limit is equal to left hand limit, so there you can write down the value for limit x tends to a f of x, but in case of discontinuity this should not be equal to f of a. Okay, so if limit x tends to a f of x not equal to f of a, then f of x is said to be discontinuous at x is equal to a. So this is the definition of discontinuity of a given function at x is equal to a. Is that clear to all of you? So these are all the theoretical of continuity of a function. So this much is for today. So you can revise it at home. you just go through the theoretical portion, just try to understand it. I think you can understand it. If you don't understand it, you can repeat the video. Okay, so again, if you don't understand, then you can comment me or you can call me. Okay, त तिमीले यो घरमा एकपल्ट रिभिजन गर हैन, बुझेन भने तिमीले रिपिट गर्न सक्छौ यो भिडियोलाई। यदि अझै पनि बुझेन भने तिमीले मलाई सोध्न सक्छौ, कमेन्टमा लेख्न सक्छौ, ठीक छ। सो दिस मच इज फर टुडे। सो इन द नेक्स्ट क्लास विल डू मोर प्रब्लम्स अन continuity and discontinuity of a function. So this much is for today. Okay.